In this video, we're going to do a walkthrough of the various cards that were used in the Microsystems International, or MIL, computers, which were known as the Mod-8 or Mod-80, depending on which cards you used. MIL was an Ottawa-based company that existed in the late 60s and up to the mid-70s. Before they went bankrupt in 1975. They were a second source supplier for Intel chips such as the 4004, 8008, and even the 8080. After the demise of MIL, the boards were still available through a company called Space Circuits and a few other companies as well. They were very popular with hobbyists because they were easy to build and the parts were readily available. The Mod-8 is contemporary with the Mark 8 and the Skelby. Now let's take a look at the boards themselves. The first one we're going to look at is the Mod-8-8. This is not a reproduction board. This is an original. I'm still working on the reproduction board. I'm awaiting some parts from China. As we zoom in, you can see there's an EEPROM burner there and many different chips which control the EEPROM burner. And on the other side here is a series of slots which hold the different cards that are used in the computer. It's similar to an S100 system, but it's definitely not an S100 bus. There's only 44 pins on these slots. The second board we're going to look at is the teletype board, which is the Mod-8-2 board. It serves two purposes. One is to communicate with the teletype machine, and the other is to do some functions when the reset button is held. If you take a look closely, there's a set of two diode arrays, which we'll zoom in and take a good look at here. The first one is a 8008 opcode for a restart 0, that is to restart at address 0. And the second one is a LAA, or a no operations code, which is done when you receive a teletype interrupt. And this board will go into slot number 1, as you can see here. And the next board we're going to talk about is the Mod-8-1 board, which is the CPU board, or the heart of the system. This board uses an 8008 Intel chip, which is a 8-bit CPU. It was Intel's second CPU. The very first one was a 4004, which was only a 4-bit CPU. The 8008 is not all that powerful, but it was sufficient for the time. And that one will go into the next slot, which is slot number 2. Here's a close-up of the chip itself. As you can see, it's only an 18-pin chip, which means that a lot of the pins have double duty. And this board here is the 8-3, which is a buffer board, which provided a bidirectional bus switch between the CPU itself and the main bus that's on the Mod-8.8 board. And it was necessary because of the limitations of the 8008 chip. And that one goes into the next slot, which is the third slot here right next to the CPU. So those first three slots are wired special. They're not generic. The next board we're going to talk about is the first of our memory boards. This is the Mod-8-4, which is a ROM board. In this case, it has 8 1702A EEPROM chips. 1702 is a very old EEPROM chip. The total memory of this is 2K. And this one ran the operating system. And this board could go in any one of these next 4 slots. It actually didn't really matter which one, and that's because you could set its own address right on the board. And you could see right here is where that's done. There's a few jumpers here. There's actually 8 combinations that can be done here, each with a 2K boundary. So the first one is 0000000, which is what this one's set to, and the next one will be 010000, etc., etc., all in split octal. This next board is the RAM board, which is a Mod-8-5. It contains 16 2102 RAM chips. In this case, these are made by Microsystems International, but Intel also made the same type of chip. And if you can zoom in, we can actually see what they look like. These are nice gold-colored chips. And believe it or not, these all work. I'm surprised when I put them in, but they all work beautifully. And this board can go into, well, any of the remaining 3 slots that are available for memory. With the ROM board, you can set the jumpers for the base address. And here I got another one. I'm going to put 2 in this case. So this one is a second one that I made up. And that, again, can go in one of those remaining 2. And here's a close-up of the jumper settings for the RAM board. It's a bit different than the ROM board. It's a bit more complicated. The bottom set will either set it at 0 or at 40,000, and the top set will add a multiple of 2K onto whatever the bottom is set to. This next board is the Mod-8-6, which is the input board, and it provides 3 8-bit input ports for the Mod-8 or the Mod-80. And that board goes into the second last slot, or it actually could go into the last slot, but namely we put it in the second last. And here's what the jumpers look like for this board, and this is to set the port addresses. So there's actually 8 port addresses available on the 8008 for input, and I believe there's 24 for output. And this next board is our output board, which is the Mod-8-7, and this is the last board we'll be discussing as part of the Mod-8 anyhow. There's another board we'll talk about which is a bit different. This has 3 output ports, and that's set by another series of jumpers, which we'll get to in a bit. But this board's a lot more complicated than the input board, as you can see. Again, that can go in the last slot, or if, like I said before, you could actually swap those 2 last boards. And this is how you would set the port addresses on this last board. It's a little more complicated than the other boards. There's actually 24 combinations here because there's 24 port addresses. And it's set using both these 2 areas on the board. And these are the pin connections to these input-output ports, and you can see the actual connections indicated below. These next 2 boards are the ones you would use if you want to upgrade to an 8080. This is the Mod-80-1 and the Mod-80-3. They would be inserted in the slots that were originally used for the CPU and the buffer board, although not necessarily in that order. And they ran faster at 1 megahertz as opposed to 500 kilohertz. And now we're going to see how that would be done. So here we're going to take out the original CPU board, which is an 8.1. And we're going to also take out the buffer board because those 2 work together. And as you can see, that's the buffer board. And interestingly enough, we're going to put this jumper board not in where the buffer board was, but where the original CPU was. And it goes right in there. It's a bit tight fit, especially when you got the other boards in there. And what we'll do is we'll put the new CPU board in where the buffer board was, which is the next slot over, of course. And then what we got to do is upgrade our ROMs. This one would have monitor 8 on it. We need to put monitor 80 on it, which comes in a set of 10 EEPROMs. We'll put the first 8 in here in the same slot that came out of. And we have 2 more, which is on a second board, which is set to address 0 20000, and that can go in the remaining slot right here. And before we end the video, I thought I'd do a brief look at a comparison between the reproductions and the originals where I have them. The first board we'll look at is the Teletype board, and here you can see they're basically the same. There's no significant differences. The only real differences you'll notice is that on the original boards, the traces were not covered by any kind of insulation or anything like that. Here's the CPU board. Again, I made every effort to make them as identical as possible. One thing that is different between the old and the new is the fact that the old boards had gold-plated edge connector lead. And this is the old and new Mod-8 3 buffer board, and again, the old board has the gold plating. Like, these boards were not proven until, of course, I got them, so I wasn't going to go through the added expense of the gold-plated edge connectors. This next board is the ROM boards, and you can see again that they're, for all intents and purposes, identical. Where I could, I found vintage type socket connectors. For this particular board, I was successful. On the original board, in this case, a lot of the chips are actually soldered onto the board. It wouldn't be what I would do, but I guess that's what was acceptable in the time, especially if you couldn't afford the sockets. Let's look at this next board. Here's the RAM boards. Again, you can see the similarity there. Another thing you might notice that is different between the originals and the reproduction boards is the any of the typeface or fonts. It wasn't possible to really do it the way they did it in the old days. At least I haven't figured out how to do that in Eagle yet. There may be a way to do it, but when I figure that out, I may try that again for future boards. And here we have the final board, which is the Mod 80-1. As you can see, they're more or less identical, though there is one difference. If you look in the upper right hand corner, you'll see a switch there, but that's actually a modification. That is not part of the original board. And that's it for this video. I hope you enjoyed it. Stay tuned for some more.